Good morning, Geometry Honors. I'd like you to watch this video on Chapter 11.0. Our algebra remediation is multiplying and dividing rational expressions. This actually may not be a review for most of you. This is not something that's often done in Algebra 1, but it's still good practice because we're going to, if nothing else, be practicing factoring. So what is a rational expression? It's basically fractions. So first, let's talk about fractions that are numerical that I know you can handle. How do we typically multiply fractions? Well, we multiply across. So we have 18 on the top and 35 on the bottom. However, when the numbers get larger, multiplying across might be annoying, especially if we have to reduce later. So if you remember, we talked about corner reducing. Now, another way you can view this is what if you break down these numbers into their prime factorization? I know this is not typically what we would do, but hear me out. By breaking down each of these numbers into their prime factorization, we now can see that if there's any numbers that match top and bottom, we can cancel them because they are linked by multiplication. I can do that here as well. So that leaves me 2 times 2 on the top and 1 times 3 on the bottom. So when we are multiplying fractions, there's nothing wrong with actually breaking them down into factors. And then, of course, as a quick refresher, when we are dividing fractions, hopefully you remember to keep change flip. So that ends up being 4/5 times 5/3. And we can corner reduce, and we have another answer of 4/3. Okay, so now let's get into expressions that actually have variables in them, so you can just see a couple of examples. So suppose I want to simplify this. Okay, now I'm sure you know you can't cancel the x's because there's minuses. We can't reduce the 5s and the 10s, etc. But factoring down and canceling factors is the way to go. So I'm going to take out a GCF in the top. I'm going to take a GCF in the bottom. Now this can factor even more because that's a difference of squares. Now, because everybody is linked by multiplication, which is like what we had here, we can cancel things top and bottom. I can cancel the x minus 2's, I can cancel the x's, and I can reduce the 5/10 to 1/2. So we have 1 on the top with nothing else. We have a 2 here, and then we have an x plus 2. And that's all that's left. Now, we can certainly distribute, but you're going to find with rational expressions, it's actually okay to leave it in factored form. So you can leave your answer like this. It's purely factored form. So I'd like to just do one more for you. So as you can see by what I'm writing, any factoring style is fair game. So if you don't know your factoring, you might want to use this time to refresh it. Okay, so again, we can't just cancel x squareds. We can't really do much unless we factor it. This problem is identical to this problem. Let's break it down into its pieces, and then we can cancel those pieces. Okay, so I did a quadratic trinomial with leading coefficient of 1. So I found a pair of numbers that multiply to -6 and add to -1. I did my difference of squares. There's nothing to do on this one. And I found my pair of numbers that multiply to 4 and add to 4. Okay, now if they're top bottom, you can reduce, or cancel, excuse me. We can corner cancel here. There's really not much else we can do. So on the top we have x. On the bottom we have x plus 3 and x plus 2. Again, I can distribute that if I wish, but I don't have to. And that is the answer. All right, good luck.